Lesson 8-4, two things. One, identifying conic sections, and then two, graphing them on a graphing calculator. So, officially there's 4 conic sections, but circles, ellipses kind of officially loop together. So, there's 3 main types of conic sections. We've talked about them, right? We did the ellipses, which an ellipse where A and B are the same would be a circle. So, and then we did our parabolas originally, and we just did hyperbolas. So, we are going to look at something called the discriminant test today. And what it is, if you are given an equation in this form, like what we had here on 50, where it is all jumbled up and, looking something like that. What it does is this discriminant test is a way, and there's a couple different ways we can do this, to be able to tell, okay, is it a hyperbola, is it a parabola, or is it an ellipse? So, note right here, there is a form, a official standard form, when it's not in the y equals, given ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So given that standard form of a conic section, if b squared minus 4ac is greater than 0, then we know it's going to be a hyperbola. And what do I mean by greater than 0? If b squared minus 4ac is what? Positive, right? If you work b squared minus 4ac and it equals 0, then you have a parabola. And if b squared minus 4ac is less than 0, you have an ellipse. What do I mean less than 0? Negative. Okay, so discriminant. Do you guys remember that vocabulary, discriminant? It's the part underneath the radical in the quadratic formula. B squared minus 4ac in a quadratic equation tells us how many solutions there are. Here, it identifies what type of problem it is. I would say a difficult part here is just you have to be familiar with this form for this to work, right? You have to know where does A come from, where does B, C come from. So notice A is x squared, B is an xy term if there is one, C is y squared. Then you have your x term, then your y term, then your constant term. And this, of course, you have to equal 0. So let's look at these real quick. Determine what conic section the following equations would graph by finding the discriminant. So I'm not asking you to graph it, I'm just, what is this? Is it going to be a parabola? Is it going to be an ellipse? Is it going to be a hyperbola? So, based on the discriminant test, and the fact that we're going to have to be able to find b squared minus 4ac, what's that mean I have to know? A, B, and C, right? So, let's go through and identify. What is 9? A. What is 16? C. What is negative 18? D. What is 64? E. And what is negative 71? F. What am I missing? So what's that mean B is? What is B? 0. Because there was no xy term, B is 0. So are we capable of doing b squared minus 4ac here? 0 squared minus 4 times 9 times 16. Right there without doing the math I can tell, yes? Why is it an ellipse? It's going to be negative, right? If you do the multiplication, it's 0 minus 576. And we know negative 576 is a negative. It's less than 0, which makes this an ellipse. So if you work this to get this in the standard form that equals 1, you would end up graphing an ellipse. If you worked and made this y equals, which is what we're going to do on the back side of the notes, then it would graph to be an ellipse. What about B? Looks a little different than anything we've dealt with this chapter, but it does fall under the conic section umbrella. Okay, there's no A or C. What letters do I have? Let's go with that. 2xy is my B term, and -9 is my which term? F. So when I do B squared minus 4AC, I can kind of already tell, but what are we going to be doing? 2 squared minus 4 times 0 times 0. And so we're going to have 4, which is what? Greater than 0. It's positive, and so that makes this a hyperbola. And C. What do you guys got for me on C? Oh, did they give us everything here? Are they in order? They are. I can't guarantee that's always going to happen, but they are here. So you've got A for the x squared, bxy, cy squared, dx, ey, and f is your constant. So discriminant, b squared minus 4ac. What's going on with what numbers am I plugging in here, I guess? B squared, 4 squared, minus 4 times 1 times 4. We're going to end up with 16 minus 16, which is 0. What's true when it equals 0? It's a parabola. Questions on those? Super duper easy after everything else we've done this chapter, right? And those should be super duper easy. There are no excuses there. Okay? Okay, the back side is we've been graphing all this stuff by hand. And which graphing it by hand has meant there is work to get it in that standard form where it's fraction plus fraction equals 1. Now, we're going to practice graphing on the calculator. That also means there's work. Even though the calculator does the graphing for us, I can't graph this until it is of the form y equals. And so that's the problem we run in here. So the goal in graphing with conic side graphers is to solve for y so that we can type it into the y equals. In order to do this, we must be able to many times complete the square. Because a lot of these terms have a y squared and a y term, maybe even an xy term. And that's where we have to look at different methods. So I've got a completing the square option for you. Some of them we'll just be able to solve. I've got a quadratic formula option for you. If we get a chance to try that as well. Okay? So, let's look at A. Thoughts on solving A? What? Well, we don't want y's and x's together. Oh, okay. Which, yes, to an extent, but what do we need on the left side? What are the only pieces we need on the left side? The y's. Okay, so, yeah, we're lumping the y's together. We're kind of lumping the x's together, but they all get to go to the right side. All we need to keep here are the y's. So if I keep the y's, that means I'm keeping what? 16y squared and 64y. I'm going to leave a gap. Equals, everybody else moves to the right. So if I move everybody else to the right, that means I'm moving 9x squared, which means it's now a negative 9x squared. I'm moving minus 18x, which means it is now a plus 18x. I'm moving minus 71, which makes it now a plus 71. Got a y squared and a y term. How do I solve? Factor out the 16 in preparation to complete the square. So this is a complete the square option. So factor out the 16, because of course we have to be in that y squared minus by. So if I factor out the 16, I have y squared. Okay, I have a mistake here, don't I? It is. Someone was going to point that out to me before we got too far, right? No, you're 2 for 2 today. I'm 0 for 2, Justin. Keep it up, okay? The only reason I caught myself is because I was looking at my notes that I always double check against to try and catch my mistakes, so that's where I caught myself. So, okay. Factor out the 16. We have what? Y squared. What's 64 divided by 16? Plus 4y. Leaving a gap. Ending my parentheses. I'm going to go ahead and write down my right side. The negative 9x squared plus 18x plus 71. Okay. This is our b over 2 quantity squared. Do you feel like you're getting any better at completing the square? I'm hoping so. We've done it a lot lately, haven't we? So b is 4. Half of 4 is 2. And 2 squared is 4. So I'm going to add 4 in this empty slot right here. If I add 4 on the left, I'm going to add what? We're going to add 4 on the right, but it's really a 4 times 16, which is what? 64. So really we're adding a 64 there is what we're adding. You're welcome to write 64. I don't care which way you write it. It's whatever, works better for you. Okay, what is always my goal after I complete the square? Next step after you complete the square is always to factor. Square root of y squared is y. Square root of 4? 2. Middle sign? Adding. Okay. Let's go ahead and clean up the right. Negative 9x squared plus 18x plus 71 plus 64, which is 135. Okay. Thoughts on how I solve for y? Okay. Yep. Divide by the 16. If we divide the left by 16, you're dividing the right by 16. So that means on the left, I'm just going to have y plus 2 quantity squared. On the right, remember, what's my ultimate goal here? I'm getting something that I can plug into the calculator. Can we plug messy into the calculator? Yeah, you can. You can plug messy into the calculator a lot better than you can work with it. So I'm going to write this as one big fraction. Negative 9x squared plus 18x plus 135, all divided by 16. If you want to make it 3 individual fractions, more power to you. Okay. If it's y plus 2 quantity squared, we want to remove that square, so we're going to square root. If you square root the left, square root the right. So now, I have y plus 2. What happens when I take the square root on the right? What do I have to put in front of that square root? Okay, you cannot forget the plus or minus, or you're only going to get half of whatever we're graphing here. And I don't know if you guys have done the discriminant test or figured out which shape this is going to be, but you have to have the plus or minus. So under that radical is negative 9x squared plus 18x plus 135. And still under the radical is it's over 16. Notice I haven't taken a square root, so that is all part of the radical. Okay. If it's y plus 2, how do I get y by itself? Subtract 2. If I subtract 2 on the left, subtract 2 on the right, you guys know how I'm going to write this? I'm going to write it as y equals, I'm going to put that negative 2 out front, plus or minus. Now, there's a couple different ways we can do this. And I'm usually pretty accepting of various options. But one thing, do you guys see something obvious under that square root? 16 is a perfect square. Can I take the square root of 16 then? Yes. So one option, and it's a pretty easy option, is to leave the radical on the top. So negative 2 plus or minus the square root of negative 9x squared plus 18x plus 135, and then put the fraction all over the whole number 4. Now, be careful. Make sure now, where's my radical? My radical is just in the numerator. Okay? Honestly, if you left it as one big radical and had 16 under the radical still, that would work as well. So this is an option. Leaving it with the radical is an option. I'm not going to force it, but technically there's one other way we can simplify this square root. Look at that numerator. Do you notice anything in that numerator? Huh? Is there a GCF? And I say even more importantly, a GCF that happens to also be a perfect square. I know 9 goes into 9x squared, it goes into 18x. Does 9 go into 135? And you'll find out it does. Yes. Yep, you're right with 15. I'll be honest, I was checking. I didn't remember. So that's another option. It's kind of our OR option. In that, and I'll write it here, still negative 2 plus or minus. And think about what happens. If you factor a 9 out here, when you take your 9 outside the radical, what does it become? 3. And so you could write a 3 in front of the radical. Then you write the radical, which means we factored out a 9. So it's negative x squared plus 2x plus 15. All over that 4 we already have. That would be yet a third way. Guys, I've given you 3 options of how you could type it in, and they would all produce the equivalent graph. Okay? I don't remember. I'm pretty sure I'm pretty flexible with it. Okay? I like this one, where you've at least taken the square root of the denominator. I have to admit that. Oh, if I had time to at least graph it. Okay. Okay. I will probably do a little bit more with this tomorrow. Because C has another option that I want to show of how we could use a quadratic formula here and stuff. So go ahead and work on it. I may go ahead and try and have the review worksheet ready to go tomorrow, but I won't necessarily have to grade this tomorrow, I guess. Okay? So yeah, you don't necessarily have to have this homework done tomorrow, I guess. I would go ahead and get started on it because I'm probably going to go ahead and give you the review worksheet tomorrow as well. But